Hello, and welcome. Have you ever wished you had a crystal ball? The power to see what tomorrow, next week, or even next year holds? It's a captivating thought, isn't it? Humans have always been fascinated by the future. From ancient oracles to modern data scientists, we're constantly trying to lift the veil on what's to come. But can we really predict the future? Today, we're diving into the science of forecasting. It's not about magic or psychic powers, but about methods, models, and the relentless pursuit of understanding patterns to make informed guesses about what lies ahead. So, what exactly is forecasting? At its core, it's the process of making predictions based on past and present data. This is typically done by identifying trends and patterns. It's crucial to distinguish scientific forecasting from fortune-telling. Forecasting relies on evidence, statistical analysis, and logical reasoning, not superstition or vague pronouncements. Think about weather forecasts. They don't just guess. Meteorologists use complex models, satellite imagery, and historical data to predict if you'll need an umbrella tomorrow. That's forecasting in action. Forecasting spans many fields. Economics predicting market trends, businesses anticipating demand, epidemiologists modeling disease spread, and even sports analysts predicting game outcomes. One of the foundational tools in forecasting is statistical modeling. Time series analysis, for example, looks at data points collected over time to identify patterns and extrapolate future values. Regression analysis is another powerful technique. It helps us understand the relationship between different variables, like how advertising spend might impact future sales. Then there's the realm of machine learning and artificial intelligence. Algorithms can sift through vast amounts of data, uncovering subtle patterns that humans might miss, leading to more accurate forecasts. These AI models learn from new data, continuously refining their predictions. This is revolutionizing fields from stock trading to medical diagnosis, offering new levels of predictive power. But it's not all numbers. Qualitative forecasting methods also play a role, especially when historical data is scarce or when human judgment is critical. The Delphi method, for instance, gathers opinions from a panel of experts through several rounds of anonymous questionnaire. This helps to reach a consensus forecast on complex issues. And let's not forget the explosion of big data. The sheer volume of information now available provides unprecedented opportunities for forecasters to build more detailed and nuanced models. Think about your smartphone, your online shopping, your social media activity. All this data, when analyzed ethically, can contribute to understanding and predicting collective behaviors. Forecasting has achieved remarkable successes. Short-term weather predictions, for instance, are now incredibly accurate, saving lives and resources by warning us of severe events. Astronomers can predict celestial events like eclipses or comet appearances with pinpoint accuracy centuries in advance. This is thanks to well-understood physical laws and precise data. In business, effective demand forecasting helps companies optimize inventory, reduce waste, and meet customer needs efficiently. This translates to better services and lower costs for everyone. Public health agencies use forecasting to prepare for flu seasons, allocate resources during pandemics, and plan vaccination campaigns, ultimately protecting community health. However, the science of forecasting has its limits. One major challenge is the existence of black swan events, rare, unpredictable occurrences with massive impacts, like some financial crises or pandemics. These events, by their very nature, lie outside the realm of normal expectations and are difficult to incorporate into traditional forecasting models, which rely on past patterns. Then there's chaos theory. The famous butterfly effect illustrates how tiny, almost imperceptible changes in initial conditions can lead to vastly different outcomes in complex systems. Weather systems, for example, are chaotic. This is why long-range weather forecasts beyond a week or two become significantly less reliable. The system is just too sensitive. Human behavior is another huge variable. We are not always rational actors. Emotions, societal trends, and sudden shifts in public opinion can defy even the most sophisticated predictive models. Think about predicting election outcomes or the next viral trend. While models can provide insights, the human element always introduces a degree of irreducible uncertainty. Data itself can be a limitation. Forecasts are only as good as the data they're built on. If data is incomplete, biased, or inaccurate, the predictions will be flawed. Ensuring data quality and addressing biases in data collection and interpretation are ongoing challenges for forecasters across all disciplines. Long-term forecasting is particularly tricky. The further out you try to predict, the more variables come into play and the higher the chance of unforeseen disruptions. Consider trying to predict the dominant technology in 50 years. So many innovations and societal shifts could occur that are simply unknowable today. There's also the psychological aspect. We must be wary of overconfidence in forecasts. Predictions are often probabilities, not certainties, and should be treated as such. Misinterpreting a forecast or placing too much faith in a single prediction can lead to poor decisions. Acknowledging the uncertainty is key. Despite these challenges, the future of forecasting is bright. Advances in computing power, AI, and our ability to collect and analyze data are constantly pushing the boundaries. Scientists are developing more sophisticated models, exploring new techniques like agent-based modeling to simulate complex systems, and incorporating real-time data streams. So, can we really predict the future? The answer is nuanced. We can't know everything with absolute certainty. The world is too complex and true randomness exists. But the science of forecasting provides us with powerful tools to understand probabilities, anticipate trends, and make more informed decisions. It helps us prepare for a range of potential futures. It's about reducing uncertainty, not eliminating it. It's about making better choices today based on the best possible understanding of what might happen tomorrow. What are your thoughts? Are there areas where you think forecasting is incredibly accurate or surprisingly off? Let me know in the comments below. Thanks for watching. If you found this exploration into the science of forecasting interesting, please give this video a thumbs up. Subscribe for more content and hit that notification bell